And so this is one of those somewhat direct images of our own uh, supermassive black hole at the center of our Milky Way galaxy, Sagittarius I star. This it is a composite image. This was put together from several detections. It's not exactly a direct image, not like you could look through a telescope and see this, because this is very far away, something like 26,000 light years away, and it's relatively small for that large of a distance. Something like, I think, the diameter of the orbit of Mercury. But the way that this image was captured is really remarkable. It's using radio telescopes positioned across the planet, and they're able to take in those radio wavelength light sources and compile them together at different locations across the planet, such that the diameter of the radio telescope is the diameter of the Earth. They turn the Earth into the objective lens of this telescope, essentially, to capture this image. But because it's kind of compiled, I do have some questions about, how much editing was done in compiling those images. Is this how direct an image this is? But nevertheless, it's definitely detecting light from our own supermassive black hole at the center of our galaxy. And, with this kind of image, with these kind of images that are being taken of our own supermassive black hole and others in other galaxies, you can begin to do direct analysis of the supermassive black hole. And indeed, what had already been done is, when you see the stars that you can detect orbiting around this, and you see their velocity, you can calculate the mass of the black hole at the center here. But with the brightness of like the accretion disk around Sagittarius I star, you can see, okay, what's the rate at which it's accreting material, forming that compact torus around it. And actually, with some of the most recent analysis that's been done, astrophysicists were somewhat surprised that the rate of material going into Sagittarius I star is just a trickle. There's only a really small amount of material going in to the black hole, so the accretion disk is relatively quiescent. It's already raising those questions. Do we as astrophysicists really understand what these objects are? Because they're supposed to be just the voracious devouring monsters just sucking everything in, but here you have a very slow, regulated. They literally called it a trickle of material coming in to the supermassive black hole. But you also have a lot of evidence of relatively recent events of activity where you have that feedback process where the central supermassive black hole is feeding material out into the galactic halo and the galaxy itself. Just another interesting note, this structure is formed from relativistic effects. So like the top part is oftentimes, depending on your perspective orientation with the supermassive black hole, it's the accretion disk behind the black hole. Gravitational lensing causes it to form this ring around it. And if there's a tilt at all relative to your viewing perspective, you get relativistic boosting of some of the light, where the Doppler boosting, where it'll either appear, depending on the orientation of the tilt, the light will be more or less luminous than it really is, due to some of these relativistic effects. And just, more ways that you're looking at a supermassive black hole when you have these kind of relativistic effects occurring.